Hey guys, welcome back to the channel. We are back with another new video for Python for Python series for beginners. So in our previous videos, we have seen about the reserved keywords, the data types, identifiers, certain rules for identifiers, and also we had seen certain set of questions which were to check whether it is a valid identifier or not. So let us see which are the valid identifiers. The first one is a total 1, 2, 3. So this is not a valid identifier because the identifier does not start with the digits. The next one was a total 1, 2, 3, and I had told that this space that has been left between the total and the 1, 2, 3 is not the space. So in that case, this is a valid identifier. The next one is Java to share. This also is a valid identifier. Next you have cache, which is not a valid identifier because it has the dollar symbol within it. Next, we have underscore ABC underscore ABC, which is a valid identifier because an identifier can start with an underscore. Next, you have def, which is not an identifier because it is a reserved keyword. Again, you have if, which is also not a valid identifier, which is starting with the reserved keyword. So I hope the identifier topic is clear. Now let's hop on to the next topic in Python, that is inbuilt functions in Python. So there are certain inbuilt functions in Python. The first one is a type. This type it is used to check which type of variable it has. Next you have ID. It is used to check or it is used to get the address of an object. Next you have print, which is used to print certain values. And in Python, everything is considered to be an object. Now let us see the data types as well in detail format. The first one we have is int data type. So we can use this int data type to represent certain whole numbers, or you can also say you can use them to represent integral values. It is used to represent the integral values. For example, 10 is an integer data type, and whenever you want to check what type of data type this particular variable has, you can use the inbuilt function type, that is type of a, and the answer will be given to you as int. So here we can represent the int values in the following ways. One is the decimal form, binary form, octal form, and hexadecimal form. So let us see them in detail. The first one is the decimal form. Let us see them in detail. The first one is the decimal form. It is the default number system in Python. A decimal form is also called as a base 10 form. It is also known as the base 10 form. The allowed digits for this decimal is from 0 to 9. So these are the allowed digits. For example, you can give the value of a 10, that is 1 and 0. Both can be used. So this is base 10 format. Next you have a binary form. So this binary form is called as base 2 form. And the digits allowed here in this binary are from 1 and 0, or you can also say it is 0 and 1, 0 and 1. So always whenever you are using binary, it is either 0 or 1. For example, the value can be represented as a is equals to 1010, or it can also be, or the value of a can also be represented as 0b111. You can ask the question now, what is this b value? What is this b value here? So this b value, it is the literal value. So any literal value can be or should be prefixed with 0b, 0b, either this one or 0 with the capital B. So this is the representation of the literal value. Next we have is the octal form. The octal form, let's do it down here, allows the digits from 0 to 7 within it. So literal values should be preferred with O and small 0 and small o, or you can also have it with a 0 and a capital O. And the values here will be represented as, for example, A value is equals to 000123, or it can also be as A is equals to 00786. So this is the octal representation of, so this is the octal form. Next one we have is hexadecimal form. How is this hexadecimal form done? So hexadecimal allows the digits from 0 to 9 and the alphabets from A to F. So here in this hexadecimal you have the values from O to 6, O to, I mean 0 to 15. So 0 to 9 as usual. After 9, that is the values from 10, 11, 12, 13, 14 and 15 will be represented as A, B, C, E, D, E and F. So this is the hexadecimal values that are present. Now for example, whenever you are going to use, or whenever you are going to give the value for A, so you are going to give it as A is equals to hexadecimal, OX is used for hexadecimal, FACE. Now this is going to be F is 15, A is 10, C is 12 and E is 14. So this is the value. So whatever line or whatever output you are going to get, that will be the hexadecimal value. Now, being a programmer, we can specify literal values in decimal, binary, octal, and hexadecimal form. But PBM will always provide the values only in the decimal form. So now let us check this in Visual Studio, like how we are going to use it. Let's create one particular program here. We have A value is equals to 10. So this is an integer value that we have got. B is equals to 00110. So this is the literal value that we have. Then C, we have it as 0xf, and we have D is equals to 0b10. Next, let us print A, print B, print C, print D. Let us save this and let us run this program. You already have this play button over here, so you can just use that to run the file. So once you run the file, you can see what is the output here. So A is integer 10, B that is 8, so we have got 8 here. So always B we have used in the octal format, so it is 8, and C, that is that it is hexadecimal format, whatever the value that we are going to get, it is giving us the value here, and D, which is in the binary format, it is giving us the value here. So I just told one note that the PBM will always provide the values in the decimal forms itself. So we have got the values here and decimal in the decimal format itself. So this is how we are going to check which particular, so we are going to get the values in spite of any of the form it has. Now let us continue. Next we have base conversion. So what are these base conversions now? In Python, it provides the following inbuilt functions for certain base conversions. So we have the base like bin, oct, hexadecimal. So how you are going to convert one value from another? So we have here, we can use this bin. We can use this bin to convert from any base to the binary digit. So you have also the value here. So you have bin is equals to 15. So this is going to convert it into binary digit. Next you have oct. We can use oct function to convert from any base to octal. Hex, we can use hex to convert from any base to hexadecimal. So let us see these three base conversions in Visual Studio. Okay, the first one that we have is the binary conversion. To convert it in the binary, I am just going to give here as bin, and this will be converted into 15. Binary conversion for 15. And okay, so now I have given a print bin of 15, so you can see that the value is 0b11111. So this is a 15 in binary. Now let us see another one, another value. Let us give here. Now let me give it for octal. So this is the octal value that I have, and I'm going to give 11. Let me just run this program here. Now you can see for the octal also it is converted in the binary. Save it and run. Remember, always you need to save the program and you need to run it. Now you can see that it is converting it, the octal value, that this octal value is converted in the binary value here. Next, you also have, in the same way, let us convert a certain hexadecimal number. So this is the hexadecimal number. Always save your program before you run it. And once when you're going to run it, you can see that the base binary digit for 10 is 10,000 here. So this is how you can convert it from binary, from any base to binary. Now if you want to convert it for octal, all you have to use is just the oct function and whatever you want to give. If it is a base 10 or it is a decimal, if you're going to convert it into octal, so this 10 in octal is 00 and 12. Now we can see it here. Now if you have any base for binary, let us see for binary. Binary 1111. Save this, run. Previously we have seen from base binary to octal. Now here we have converted from octal to binary. You can just check it out here. Now in the same way you have it as hexadecimal. If you want to convert for hexadecimal, you can just use hex and that particular function from the binary base to hexadecimal base. So this is how you're going to get it in hexadecimal. So it is 15 in hexadecimal. In the same way, if you have 100 in hexadecimal, save it, run the program. Now we can see 100 in hexadecimal is 64. So this is how you can convert from one base form to another base form using these three inbuilt base conversions. So this is all for today's video. Meet you again in the next video with some other contents. Till then, stay tuned and keep learning. Bye bye.